Hello, and welcome to this presentation of the STM32C0 USB 2.0 full-speed interface. It covers the features of this controller, which is widely used to interface with a host computer. This figure illustrates the connections between an STM32C0 microcontroller and a USB connector. The STM32C0 supports a USB 2.0 full-speed communication interface, enabling it to easily connect to a PC. Typically, it functions as a USB peripheral device. It offers 8 bidirectional endpoints and is compatible with the Battery Charging Detection Specification version 1.2. Key advantages of this setup include crystal-less operation, energy efficiency, and faster charging, thanks to the integrated charger detection feature. Let's explore some key features of the USB full-speed interface. It is USB 2.0 compliant and operates at a bit rate of 12 megabits per second. The interface allows for the implementation of a USB full-speed device and supports crystal-less operation. It can manage up to 16 endpoints, including 8 bidirectional ones, with full support for isochronous endpoints. Bulk endpoints benefit from a double buffering mode, improving overall performance. The interface also supports link power management, adding enhanced power modes beyond the USB 2.0 specification. Additionally, battery charger detection allows devices to draw up to 1.5 amps from BC 1.2 compliant chargers, enabling faster charging. This block diagram of the USB full-speed device controller highlights its internal components, along with the analog transceiver that manages the physical layer, as shown above. 2 clock domains are implemented. The PCLK domain, that includes the interface to the APB bus. The USB kernel clock domain, that includes the transmit and receive state machines running at the USB 2.0 full-speed bit rate. The physical layer, or PHY, handles analog signal levels, including level detection and battery charger detection functions. USB interrupts are sent to the Cortex processor to signal various USB events. The APB peripheral bus enables read and write access to the controller. Additional key elements include the packet buffer memory and a suspend timer, which supports low-power operation. Several related peripherals work alongside the USB device controller to manage USB activity in connection with system power modes and software requirements. The clock recovery system eliminates the need for an external crystal by using the integrated HSI USB48 oscillator as the main clock source. Interrupt events are directed to the Nested Vectored Interrupt Controller, or NVIC, through a single line. Additionally, system events, such as resuming from USB suspend mode, can wake the system from stop mode. The USB device controller generates interrupts under various conditions, typically requiring software handling. The first 2 interrupts address different error and warning conditions, while the remaining interrupts correspond to standard USB protocol events. In run mode, the USB peripheral remains fully active. After a suspend event, the microcontroller can enter sleep mode, as well as stop 0 and stop 1 modes. Stop 2 and standby modes should be avoided. Some debugging support is available through a single status bit, which corresponds to an interrupt event. Within the USB device controller, the ERR status bit provides helpful debugging functionality by signaling various events, as shown in this table. Additionally, the D+ and D- line states can be directly read through RxDP and RxDM bits for further insight. This is an example of a low-power peripheral device application. The device draws power directly from the USB V-bus signal, and no external crystal is needed. This slide shows an application example of a USB high-speed peripheral connected to a USB Type-C connector. Power is supplied through the USB V-bus signal, and two 5.1 kilo-ohm resistors need to be added to the CC lines. For complete USB specification documents, please visit usb.org. The USB 2.0 document homepage offers a zip file containing the USB 2.0 and OTG 2.0 specifications, along with an engineering change notice, or ECN, for link power management, or LPM. The USB device class documents page contains the battery charger specification. Additional information can be found in the listed application notes. Thank you for attending this presentation.